Namaskar. I am Dr. Nisharani, Superintending Geologist from Photogeology and Remote Sensing Division, Geological Survey of India Training Institute, Hyderabad. My lecture is on Introduction to Digital Image, and during my session I will discuss about digital image, digital number, pixel and different types of resolution. There are two types of remote sensing data products. One is pictorial data, another is digital data. Pictorial data means your satellite data is in the form of hard copy, and digital data means when the data is available in the soft copy. And here we can see if your data is like this, printed in hard copy is your pictorial data, and once your data is soft copy, so you can see your data in a computer only. That is called your digital data. Pictorial data. Pictorial data gives information in the form of images and aerial photographs. These are generally taken by sophisticated cameras and uses only visible portion of the electromagnetic spectrum. Therefore, aerial photographs give exact view of object on a reduced scale. The images may be in black and white or color. It depends on the camera. Digital data. The images provided by satellite are called satellite images. These images are taken by sensor which uses visible, infrared region and microwave region of electromagnetic radiation. Satellite images may be black and white or colored. What is digital image? Digital image is an array or matrix of numbers depicting spatial distribution of certain field parameters such as electromagnetic radiation, emission, temperature or some geophysical or topographical elevation. In other way, a digital image consists of discrete picture elements called as pixel, and each pixel is associated with a number known as digital number, or sometimes it is called as brightness value, that depicts the average radiance of a relatively small area within a scene. Here we have one imagery, and if you zoom it, you will see these small areas, and these areas are basically pixels, and these pixels are basically depicted by certain numbers. Here we can see these are actually brightness value. Here concept about digital image and pixel will be clear. This is entire area is called as pixel, and if I'll zoom this particular part, you can see this, and this small area is actually pixel. Digital image can be in panchromatic or multispectral or hyperspectral data sets. Panchromatic means the images are in 2D array of pixels, and multispectral and hyperspectral images means 3D pixel arrays. In a digital image, the x-axis is column and y-axis is row, whereas z-axis represent band number or wavelength. Here we can see we have one panchromatic image which is in 2D, two-dimensional, whereas multispectral and hyperspectral we are having more bands, so it gives 3D view of the data. Pixel or cell. An image consists of tiny equal areas or picture elements arranged in a regular rows and column is called pixel or picture element, and representing area covered on Earth's surface is one pixel. The position of any pixel is determined on XY coordinate system. Each pixel also has a numerical value called as digital number or DN that records the intensity of electromagnetic energy measured for the ground. The digital number is average radiance or reflectance of a smaller area, which is called ground resolution element or GRE. Pixel represents individual area scanned by the sensor. Smaller the pixel, the easier it is to see details of an area. Here one example is given. This is the aircraft which is scanning the area, and this is called your scene. In that scene, this is the smallest area which is known as ground resolution cell or pixel. If we'll increase the size of the imagery, or if we'll zoom the imagery, this type of picture will come, and these tiny small areas are actually pixels, and these pixels are having some numerical values, that is known as digital number. Digital numbers are stored as binary digits in a computer. The value represented in grayscale is represented by certain numbers, and that ranges from 0 to 255. 0 represents black and 255 represents white. Here we have one example. We can see there is some small pixels, and each pixels are having some digital number. These digital numbers are basically represented in terms of brightness value, and these brightness values are represented in terms of gray. And here we can say if you have 0 brightness value, then object will be black. If it's ranging between 0 to 255, it will be gray, and if it's a 255, then it will be white. Digital number basically represented in terms of bit. So if you have 1 bit data, you have 2 levels of grayscale, and if you have 2 bit data, then 4 level. If you have 8 bit data, you have 256 level of grayscale, and if you have 12 bit data, then you have 4096 level of grayscale. So you are going to get more and more information if you will go from 2 to 12. You have one quiz. A digital image is option 1 spectral, option 2 arrays of numbers, option 3 temporal. And the right answer is option 2 arrays of number. Another quiz. 8-bit data poses a range. Option 1 0 to 255, option 2 0 to 65533, option 3 0 to 224. And the right answer is option 1 0 to 255. Resolution in remote sensing is very important. Resolution of an image refers to the potential details provided by the imagery. There are 4 types of resolution. One is spatial resolution, second is spectral resolution, and third one is temporal, and fourth is radiometric resolution. I'll discuss one by one in a detail. Spatial resolution. The Earth's surface area covered by a pixel of an image is known as spatial resolution. Large area covered by a pixel means low spatial resolution, and vice versa. Spatial resolution means smallest unit area measured on the ground. Here we can see this is representing 1 pixel, and here we are seeing that large area is covered in a pixel, and if we'll go here, a small area is covered in a pixel. So this is very poor resolution data, and this is very high resolution data. Here we are not able to see any detail of the area, but here we can see each and every detail of the area. That is called your spatial resolution. Spectral resolution is the range of wavelength that satellite imaging system can detect. It refers to the width and number of spectral bands. Narrower the band, the greater the spectral resolution. It describes the specific wavelength interval in an electromagnetic radiation that a sensor can record. High resolution sensors can discriminate very fine differences in spectral reflectance. Here some examples are given. We can see low resolution spectral bands where one band is there, blue, green, red, it's covering entire range, and here higher resolution band is there, blue, green and red. 3 bands are there. So resolution of this band is better than this band, and here we can see we have one electromagnetic spectrum where we can see we have certain bands here, certain bands here, and certain bands here. And for the hyperspectral band we can see contiguous bands are there. So we are going to get better information in this particular region rather than this and this. And if we'll compare this and this, then we are going to get information here, better information in this band. And if we'll see this, we have one black and white or in a grayscale image. You can see we are not able to make much differences in this photograph, but if we have more bands, so you can differentiate in a better way. Temporal resolution, the frequency at which images are recorded or captured in a specific place on the earth is called temporal resolution. Means revisit time of the sensor is called temporal resolution. The more frequently it is captured, the better or finer the temporal resolution is said to be. The Landsat series of satellites have a repeat period ranging from 16 to 18 days, whereas in the case of IRS it is 22 days. Temporal resolution is very important when we want to see some changes in the area. This imagery is of the year 2004. Before tsunami, we can see the area, how it's looking, and after tsunami, all area devastated. So such kind of studies can be done with the help of temporal data. This is another example. For illegal mining, this area was monitored, and we can see in 2016 this area was like this. The same area in 2016 we can see here. So whatever changes are here we can see. Radiometric resolution, sensitivity of a sensor to the magnitude of the received electromagnetic energy determines the radiometric resolution. Finer the radiometric resolution of a sensor, if it is more sensitive in detecting small differences in reflected or emitted energy. Here we have already discussed about the radiance or DN value. DN value basically represented in grayscale, so 0 to 255, and it is normally radiometric resolution basically represented in terms of bit. Here concept of radiometric resolution will be clear. We have 1 bit data, 2 bit data, 4 bit data and 8 bit data. Here in 8 bit data we are getting 256 gray shades, means finer details we can see in this image, whereas in 1 bit data we are getting only 2 gray shades, so we are not able to identify the finer details of the image. Similarly here we can see 4 bit data and 8 bit data. 8 bit data is better than our 4 bit data. Another quiz. DN defines option 1 derivative number, option 2 digital number, and the correct answer is option 2 digital number. There is another quiz. Which among the following is a resolution? Option 1 image, option 2 spectral, option 3 specular. And right answer is option 2 spectral. Thank you. This is the end of the current session, and the next session will be on different types of error and correction in remote sensing data. Once again, thank you.